Section 2.3 is about graphs of functions, both if it was a scenario where you were given a function and you had to construct its graph, or if you were given a function's graph, what kind of information you could get out of it. The first thing about if you're given a function, then to construct its graph, that is no different than graphing an equation. I guess the only real difference is that there would be an f of x instead of a y. So the notation would look different. But other than that, what you do is identical, which is why I have number 1 and number 2 already written in here. Because this, if we had to graph f of x equals x squared minus 2, basically what you would do is that you would pick out some x values to then substitute in. And that's basically what I did here, which really is no different to if you're just graphing any old equation, picking out some x values and seeing what you get for y. Right? Assuming that you had your equation solved for y, it would be this exact same process. It just looks different because it says f of x instead of y, but you do end up doing exactly the same things. So like if we pick out 0 as an x value, then f of 0 would be 0 squared minus 2, but 0 squared 0, so you eventually end up with negative 2. And then there's that point right down there at the bottom, right? So there's the 0, negative 2. With 1, f of 1 is 1 squared minus 2, but 1 squared is 1, so you end up with negative 1. So 1, negative 1 is right there. If you sub in a negative 1, negative 1 squared is also 1, so you get the same y value. So there's negative 1, negative 1. If you sub in 2, that's 2 squared minus 2, so 4 minus 2, which is 2. So 2 is right there. And then negative 2, if you square negative 2, you're also going to get 4. So you end up with the same y value, and right over there is negative 2. And then you could go farther if you want to. If you evaluate the function when x equals 3, you're going to get 7, which I sort of couldn't draw because this only goes up to 6. I guess it would be like right about here. And then f of negative 3 would be negative 7. So that's why the arrows are on here. Like this would just keep going if you went farther out away from 0 with your x values in either direction. So like 3, 4, 5, 6, and then negative 3, negative 4, negative 5, negative 6. In either of those ways of getting farther away from 0, you're going to end up with bigger y values. So that's what the arrows are for on the ends there. But I mean, if you look at what happens here, it's not really any different than what we would do just to graph an equation like we did in chapter 1. Same thing here. So this one's got an absolute value in it, which does make it look a little bit different because the absolute value isn't something that you see every day, right? But we can handle that one. I mean, if you know what to do with it, if you're comfortable with it, that actually might be easier than the squaring. Because really the absolute value is just, like if you're taking the absolute value of a number, it's, well, how far away is that number from 0? So if you have a positive number, it's just that number. If you have a negative number, effectively you just end up dropping the negative sign. So let's see, if we want f of 0, then the absolute value of 0 is just 0, right? So we have the absolute value of 0 plus 1, but that's 0 plus 1, so 1. So 0, 1, there's that point right there. Then if we substitute in a 1, f of 1 would be the absolute value of 1 plus 1, but absolute value of 1 is 1, so it's 1 plus 1, which is 2. The absolute value of negative 1 is also 1, so this also ends up being 2 when we set x equal to negative 1. And then for 2 and negative 2, you're going to get 3, right? Because I'm looking at what we have here, and you can kind of tell based on what happened up there. The absolute value of negative 2 is going to be 2. So f of 2 and f of negative 2 are both 3. So like there's 2, 3, there's negative 2, 3. And then I put negative 3 in here, but you would get the same thing with positive 3, right? So f of negative 3, you're going to get the absolute value of negative 3 plus 1. But the absolute value of negative 3 is 3, so 3 plus 1, that's 4. There's that point. And if you subbed in a positive 3 instead, you would get 3, 4, which is right there. And absolute value functions generally have kind of a V shape. So that's, I mean, my drawing is a little imperfect. These could be a little bit straighter, but it's kind of hard to pull off with a tablet. So sorry about that. I know that doesn't look all that great, but it should just be like a nice hard V shape. And that's what absolute value functions look like. All right, so there's that part, which is not really all that different. The part that's newer, I think, is what happens here. Even though we had situations before, like with relations even in the beginning of chapter 2, where it was, here's the graph, figure out the domain and range. We didn't always talk about this other stuff, like the intercepts and the zeros. And the zeros actually are the x-intercepts, effectively. So in a way, this is not going to be an extra thing when we get to it. But really what those are, and I think I can squeeze this in. Maybe if there we go, give myself a little more room. So what the zeros are, those are the values of x such that f of x equals 0. So they're the x-intercepts. Well, I guess they're the x-coordinates of the x-intercepts because, in theory, you're supposed to write out the x and y-intercepts as ordered pairs, like their actual points. So the x-coordinates of the x-intercepts then would be the zeros. But still, you're looking at the points where the graph is going to cross the x-axis. That's where you're going to find them, which is the same place you would find the x-intercepts. So basically, you're looking for the same stuff. All right, well, the domain and range first, I suppose. So the domain, the x values are being covered by this function, by its graph. Well, since there are arrows on the ends, and this arrow down here is going downward to the left, this one up here is going upward to the right, then as far as like the left and right are concerned, any x value that you want to pick, that function's eventually going to hit it. So because of those arrows, everything's going to be covered. So the domain would then be all real numbers. Or if you wanted to write that as an interval, it would be the interval from negative infinity to positive infinity. Right? Because everything's covered in there. And just like before, when you have the negative infinity or positive infinity that you have to have stand in for an endpoint, those aren't actually numbers, right? Those are more like concepts. So it's always a parenthesis, right? You never include the infinity or the negative infinity since those aren't actually numbers. But by the logic that we use to say that the domain was all real numbers, the range is also going to be all real numbers because anything that you want to pick that's way down here, eventually this graph's going to get down there. And then any y value you want to pick that's like maybe way up here, on this end, it's going to keep going upward, so it's eventually going to get there. So the range is also going to be all real numbers. So the range would be all real numbers. Or if you'd prefer it written as an interval, the interval from negative infinity to positive infinity. All right, next is the intercepts. All right, I guess we can just do them in order. So for the x-intercepts, those are going to be the points where the y-coordinate's 0, right? So then what we're looking at would just be where does this graph intersect the x-axis, and it's right here. So at the point 4, 0. And then for the y-intercept, it's, well, where does the graph intersect the y-axis, which is right here. So it's 0, negative 2. And I should point out that with a function, you can have multiple x-intercepts. And we'll see that. Actually, if I scroll down for a second, that's got multiple x-intercepts because it intersects the x-axis in two spots, right there and right there. And you can have more than that, right? I mean, you could have 15 x-intercepts. That'd be a crazy looking graph, but you could have one. However, you can only have one y-intercept with a function. With a relation, you can have more than one. But if it has to be a function, then if there were multiple y-intercepts, the graph would fail the vertical line test. Because then if you picked your vertical line to be the y-axis, it would intersect the graph in multiple points, and then it wouldn't be a function. So for functions, you can only have one y-intercept. But you can have a bunch of x-intercepts. Even though here we just had the one, you can see what's common. Like with number 4, there are a couple of them. And then I guess the last thing is what zeros do we have? Well, if those are the values of x such that f of x equals 0, it's just the x-coordinates of the x-intercepts, right? Because if 4, 0 is on this graph, that would mean that f of 4 is equal to 0, right? So that's what you could get out of this. And then here, I guess you could say, even though we're not using this right now, that f of 0 is negative 2. But yeah, the x value that would make f of x be 0 is 4. So the 0 is just x equals 4. And that's it. You don't really have to do any extra work there if you already know what the x-intercepts are. All right, next, number 4. So this one's got multiple x-intercepts. So that's new, I suppose. But then as far as the domain goes, notice we got arrows on the ends again. So you go, all right, well, what's the point that's farthest to the left? There isn't one, right? Because this keeps going upward and to the left. So any x value you pick way out here, eventually this is going to get there. Same thing over here, right? We got this arrow going upward to the right. So any x value you pick way out here, eventually it's going to hit it. So the domain is going to be all real numbers. So I guess I'll just jump right to the interval this time. But then what about the range? There's no highest point because of these arrows, but there is a lowest point, which is down here. Also looks like it's the y-intercept. So this point right there looks like it's 0, negative 4. So negative 4 is the smallest y value on this function. So what we're going to get for the range, and this might be easier to write this in set notation first. So that's what I'm going to do. I'm going to say it's the set of all y values such that y is greater than or equal to negative 4. Because we do get the negative 4 down there, but then we get everything above it, right? I guess on either side of this parabola shape. So like that, or if you would prefer it written as an interval, negative 4 is going to be the lower or left endpoint of the interval. So negative 4, which we're going to include, right? Because that point is part of the graph. But there is no highest y value, so there's no upper endpoint. So we need infinity to stand in parenthesis around that. Then the intercepts. So the x-intercepts, we said there are 2 this time. So one's right here and one's right here. It's the 2 points where that graph is going to cross the x-axis. So negative 2, 0 is one of them. And 2, 0 is the other. And then the y-intercept kind of already said what it is, right? It's right there, right? Generally, I guess, by definition, the point where the graph crosses or touches the y-axis, but we've already figured that out. So the y-intercept would be the point 0, negative 4. And then the zeros, so the x values where f of x equals 0, just the x-coordinates of the x-intercepts. So x equals negative 2 and x equals 2. All right. Then even more x-intercepts. And this one, and I know this feels a little bit confusing, but it shows up occasionally on the homework, so I wanted to have this happen, where one of the axes is not calibrated going by ones. So here the y-axis is, right? You can see 0, 1, 2, 3 like we would normally have. But then notice the x-axis is going by 2s. So 0, 2, 4, right? You don't have the 1, you don't have the 3. And so then there are points where even though they're not explicitly labeled along the axes, you have to kind of figure out what they are. And I wanted to have that happen somewhere. So we've got it here. Although the x-coordinate of that's actually kind of hard. So that one, if you can't see it, I wouldn't worry about it. But then like that one, I think isn't too bad to figure out. Neither is that, and then neither is that, right? So, and then neither is that. But the x-coordinate of this point down here in the lower left is supposed to be negative 1.5. So that's a little hard to see here. But the domain, so it would be all the x values between negative 1.5 and then over here 4, since this is the point that's farthest to the right. So if you wanted to write that out just as an inequality first, maybe, to say like it's negative 1.5 less than or equal to x less than or equal to 4, and then that would tell you that as an interval, it would be negative 1.5 to 4, like so. Then All right, well then we can also do the range without too much trouble because we've got a lowest point and a highest point this time. So it looks like what we would have for the range is that the lowest point has a y-coordinate of -2. And then the highest, that looks like 2.5 up there, right? Halfway between 2 and 3. So -2 less than or equal to y less than or equal to 2.5. So then it's from -2 to 2.5. All right, then x-intercepts, we've got 3 of them because the graph is going to cross the x-axis right here, but then twice on this side, so right there and then right there. So we've got 3. And it looks like the x-coordinate here is -1. Looks like this one over here is 3 since it's halfway between 2 and 4. So it looks like what we should get would be -1, 0, 2, 0, and 3, 0. So 3 x-intercepts this time. Still just the 1 y-intercept. This, for some reason, this graph looks slightly off on this part. I don't know why, but it's supposed to be 1.5, right? It's not supposed to be some weird, obscure number. It looks like it's very slightly too low somehow, but it is supposed to be 1.5. So the y-intercept then would be the point 0, 1.5. And so then our zeros, which just go right back to the x-intercepts. So just those x values. So it's x equals -1, x equals 2, and x equals 3. Okay, then number 6. So for that graph right there, if we're going to find the domain, the range, and the intercepts, all right, well, we do have, and I guess we can label the points here too. There's the point that's farthest to the left. So like for the domain, we want farthest to the left, farthest to the right. So let's see, this is -5, -2, it looks like. And then the one that's farthest to the right is right there, so it's 5, 0. And then for the range, because we're going to need this in a minute, we want the lowest point and the highest point. The lowest point's this one, right? It's the -5, -2. The highest point is actually up here, right? It's right at the top of this peak. So this is going to be 2, 3. All right, so then finding the domain, range, and intercepts. So the domain, let's see. So -5 being the x-coordinate of this point farthest to the left, and then 5 being the x-coordinate of the point farthest to the right. It looks like we're going to get the interval from -5 to 5. And then for the range, let's see, the lowest point's there, the highest point's there. So the y values, so down here, the y value is -2. Up here, it's +3. So it looks like we've got -2 up to +3. Right? Oh, and I did want to write in, if you were going to write these in set notation, even though like the homework would probably ask for it as an interval, you could write them in set notation. I did want to squeeze that in here. So like this one would be the set of all x such that -5 is less than or equal to x less than or equal to 5. And then this one, I guess I should write it underneath so I don't write into the picture. You could write it as the set of all y such that -2 is less than or equal to y is less than or equal to 3. And then the intercepts, let's see, we've got one x-intercept right here, and we've got the other one over there. So the x-intercepts are going to be -3, 0, and 5, 0. And then the y-intercept, looks like it's right there. That's where the graph's going to cross the y-axis, so 0, 2. So the y-intercept would be 0, 2. Part B is a little bit different. So to find f of negative 3 and f of 2, basically what you would do for something like that is that you just have to see, well, where is, like when x is equal to negative 3, like where is that along the function, and then just what's the y-coordinate of that point. That would basically do it. So f of negative 3, if we go over to where x is negative 3, the function's right there, so it's 0. Right? So f of negative 3 is 0 because when x is equal to negative 3, that function's right on the x-axis. And then for 2, if we go over here to where 2 is, and then we say, all right, when x equals 2, the function's up here. So the y-coordinate of that point is 3, so that is f of 2. So f of 2 is going to be 3. All right, then part C, for what numbers x is f of x equal to 1? So on the graph, that would be like saying, if y is equal to 1, what's x? So I guess I'm going to make like a dotted line for where, because f of x equals 1, the graph of that would just be y equals 1, right? So I'm going to make a dotted line just to kind of show where that is. Right, so that's f of x equals 1 right there. And then where, where along the function do you get f of x equal to 1? Well, you'd get it right here, and you'd get it right there. So it looks like that f of x equals 1 when x equals negative 2 or x equals 4. I guess another way to look at this would be to phrase it this way, to say that f of negative 2 equals 1 and f of 4 equals 1. Right, either way. So what you end up with as an answer then would be x equals negative 2 and x equals 4. Right, those are going to be the two x values for which f of x is equal to 1. Right, because if you go just along the graph here, there's negative 2, so f of negative 2, we look up there, that's 1. And then for 4, it's the same idea. D is a little weird, actually. So for what numbers is f of x equal to 2? All right, so I can kind of do the same thing and make a dotted line. But there's like this horizontal part of the graph right here where everything between negative 1 and 1, all those x values, so f of any x in there, you're going to get 2. So that is the case, even though we also get this point here, and we're going to get this stuff, right? So, all right, let's see what we got. I guess I have to kind of squeeze this in down here because I want the graph to be visible while I'm talking about this. So hopefully this is enough space. All right, so I guess we can say that f of x equals 2. I'll do the point first. So when x equals 3, right? Because that's this point right there. But then the other part of it is that f of x equals 2 when x is between negative 1 and 1, right? Because we got this flat part like right through here where for f of 0, that's 2. For f of 1/2, that's 2. For f of negative 3/4, that's 2. So I guess then we'll say when negative 1 less than or equal to x less than or equal to 1, right? Because it looks like it works for those endpoints, negative 1 and 1, and everything in between. So knowing that, what that would tell you, I guess this is how I can write this and squeeze it all in on the screen without having to scroll. So I guess the answer would be x equals 3 and negative 1 less than or equal to x less than or equal to 1. Or if you would prefer this written in interval notation, because this thing over here, clearly you could write as an interval. So let's see, you could write it as, so the closed interval from negative 1 to 1 union with the set that just has a 3 in it. That's really kind of weird looking, because usually if you have a union, it's a union of one interval with another interval, not an interval with a point, but that's kind of what we got here. So this one is a little bit weird because of that flat part of the graph where we ended up with an interval, where anything that interval is going to work. I think usually for for these sorts of questions when they show up in like in the homework, that they're more like part C than part D, where I don't think you get those flat parts. I think it's more just like find the points that are going to work for this. Find their x coordinates, right? Because you already know what their y coordinates are. But I thought, just in case, I should put something like D in there. Sorry, I didn't mean to move that. I just kind of brushed up against my mouse. But that, I think, would cover everything in section 2.3. So all of this graphing stuff.